Okay, we have a few quiz problems here. I'm going to solve showing steps. I didn't include in the instructions that I wanted you to check because I want to see if anybody's in the habit of checking. A couple of people I think did check at least one problem, and that's a very good sign. Okay. Again, the reason you check problems is so you immediately know that you did something wrong instead of going on and keep, continuing to do the wrong thing again and again. It really confuses the learning process if you get in the habit of doing something wrong. So if you're always checking, you're much less likely to fall into that trap because it's a big trap. It's hard to get out of that one. Okay. So we've got 5x equals 24. What do we do to both sides? Well, trying to find x, and x is multiplied by 5. If we divide something that's, well, if we divide 5 times something by let's see if I can say it right. If we divide 5 times a quantity by 5, what do we get? We get the quantity, right? Yeah. If we divide 5 times 3 by 5, we get 15 divided by 3, that's 3. Okay, well, for a lot of reasons, we can then undo this multiplication by division. We have 5x over 5 equals 24 over 5. And the 5 divides the 5, leaving us x equals 24 fifths. I think everybody went ahead and said, okay, that's 4 4/5. I'm not even going to mention it because it's not important in this, usually not important in this course. Okay. But sometimes it is, so you want to be able to do it. Like if you want to put that number on a number line, 4 4/5, you know where to put it between 4 and 5, right? 24 fifths. Well, you divide your whole number line into fifths and count 24 of them. Okay, that's impractical. So you don't do that. You use 24 fifths. Now we check. We substitute the 24 fifths. And we see if that works. Now we don't cancel, we don't put lines through this, we multiply it out. Five times 24 is 120. I discourage the use of calculators for the simplest arithmetic. And if you can't do that in your head, it's illegal to punch that in the calculator, okay? And that gives us 24 equals 24. And now we're done. Okay. Well, the next one is x plus 7 equals 16. Can everybody read this out the way we talked about last time? If you add 7 to a number and then subtract 7, you get the original number. Okay. So subtracting 7 undoes the addition of 7, and you end up with just x. And of course, we have to subtract 7 from both sides. 16 minus 7 is 9. So we're done very quickly. Check. We substitute 9 for x. 9 and 7 is 16. You count that in your fingers if you've got enough fingers. But everybody knows that 9 and 7 is 16. So good there. Okay. Now, everybody did these and they did them correctly, and I'm very happy about that. And everybody showed, I think, the same steps on Friday. Okay? So they were spending a little too much time with this explanation, but I really want to emphasize that you want to follow the steps, because today we're going to talk about longer linear equations. We're going to use the same steps, but you got to be careful how you put them together. And then there are a couple of new wrinkles that we're going to talk. Okay, so now actually, I believe this goes a little beyond the homework you did on one-step equations. This is actually a two-step equation. But everybody got it right. Okay, what's the first thing we want to do to this equation? Well, I can write it out. 5x plus 7 equals 30. There's room to do something else. Okay. You might want to divide the 5x by 5. Okay. Well, you can't just divide the 5x by 5. You have to divide the whole 5x plus 7 by 5 because you have to divide both sides by 5. However, we're not going to do that in the first step. You could, but you'd end up with fractions that wouldn't be particularly efficient to do that. Okay. Usually, you're going to try to undo additions and subtractions before you do multiplications and divisions. So we're going to do subtract 7 on both sides. And of course, 7 minus 7 is 0. That leaves us 5x here. 30 minus 7 is 23. So that's one step. I mean, it took 2 steps to do it, but that's the first operation. Okay, we subtract 7 from both sides. Now we divide both sides by 5. Leaving us x equals 23/5. Now we'll check. So we write the equation out, but we replace x as 23/5. Here's what we get. Let's say multiply out the 5 by 23. 115 over 5 plus 7 equals 30. Divide that out, you get 23 plus 7 equals 30. 23 plus 7 is equal to 30. So we've checked and we're done with that problem. Okay. Now there is another way to solve it. And I'm going to demonstrate what happens. I have 20 boards, 20 minutes on it, we have 20 boards. I'm going to demonstrate what happens when you try to divide just 5x by. Okay, so we've got, yeah, our equation is 5x plus 7 equals 30. This is wrong. We'll prove it's wrong because it's not going to check. Okay. 5x over 5 plus 7 equals 30 over 5. Okay, well, 5x over 5 is x. We get x plus 7 equals 6. So we subtract 7 from both sides. X plus 7 minus 7 is just x. 6 minus 7 is -1. Yeah. We substitute -1 for x. There's substitute -1 for x. It gives me -6 plus 7 equals 30. No way you're getting 30 out of 6 and 7, no matter how you combine them. But I've got a question. So let me pause for a second, answer the question. Okay, so we have -6 plus 7 equals 30. You're not getting 30 out of that. You add -6 and 7, you get 1 equals 30. And I'll say no. And that doesn't work. So that solution's incorrect. Okay. Now, if you want to divide, if you want to start dividing by 5, you can do this. 5x plus 7 equals 30. You can divide 5x plus 7 by 5. And that would equal 30 divided by 5. Okay. But notice I divided the whole 5x plus 7 by 5, which means that I've got 5x over 5 plus 7 over 5. And of course, 30 over 5 is 6. Right. Which means I've got x plus 7/5 equals 6. Now we've got a fraction in there. And if you compare with the solution we had over here, the only fraction we got was at the very end. Okay. So we're going to have to do a little work to deal with that fraction. We're going to have to find the common denominator. Well, let's see how that works out. We've got x plus 7/5 minus 7/5 equals 6 minus the 7/5. Okay, well, clearly 7/5 minus 7/5 gives us 0. That leaves us x over here. It's 6. Okay, well, we've got to use the common denominator. And say, okay, well, that's 6 times 5, 1 times 5, minus 7 over 5. X equals 30 over 5, minus 7 over 5. So that x equals 30 minus 7 over 5. So x equals 23/5. Now that's a lot more work than what we did over here to get 23/5. Okay. Now I'm not going to write out the check again because we already checked 23/5. We know it's correct. But if you've done this, then you want to do the check and you'd say, okay, it worked out. And you take a deep breath and say, yes, it seemed more complicated than it should have been. Well, yeah. When you're dealing with equations, you want to avoid fractions as much as possible. And we're going to see that here in a little while when we do a few more linear equations, okay? So, I'm going to go on and go on and do that. Okay. But you, since you're already have done pretty well with a couple of two-step equations, I'm going to write out some equations that we need to use multiple steps in order to solve. Okay, let's. And I'm going to ask you to work on it. Okay. See how you do. And see where you get stuck. And if you don't get stuck anywhere, that's even better. But there's some sticking points in some of these problems. Usually cause people stumble a little bit. Okay, let's try 5 times x plus 3 equals. I'm going to take that back. I want to do something like that. I want to do that after I do this. Okay. First of all, let's try x plus 4 equals 5x minus 3. See how we can do with that. And then step 2 to illustrate an important property, an important technique. Okay, first, everybody got the first one, but there's one solution that didn't show me the steps. And I'm not sure how that solution was arrived at, so we have to see how to document this. However, if you were able to get the thing without doing these steps, I gotta say that's pretty good. Still, I need to see the steps. Okay. Okay, so we have 3x plus 4 equals 5x minus 3. Ultimately, we want to get x equals something. Meaning we want to isolate x on the left side. Now, since we've got x's both on the right and the left, any x's that are on the right, we're going to want to have end up on the left. We want to get rid of any x's on the right, basically. So the only place we have x's on is on the left. And similarly, we want to end up, well, we want to get rid of any numbers, pure plain numbers on the left. And that way our numbers will all appear on the right. And that's pretty much what I saw people doing. They followed all the steps. So the first thing we're going to do is we're going to work on the numbers rather than the x's. And we're going to get rid of the 4. And to get rid of the 4, we're going to subtract 4 from this side, meaning, of course, we have to subtract 4 from this side so the equation doesn't go out of balance. And that's going to just leave us plain old 3x on this side. Now, at this point, we might say, okay, we got 3x there. We divide both sides by 3. Well, that's not going to work because there's still an x over here, and you want x equals some number, not x equals some expression that has an x in it. So we're going to subtract the 5x from both sides. In other words, we don't want the 5x over here. Okay, so we want 3x over here. 5x minus 7 here. Now we're going to subtract 5x this side. That'll get rid of the 5x over here. Then we subtract 5x from this side. We have what you see, 3x minus 5x. And then 3x minus 5x is negative 2x equals negative 7. I saw the same solution on a lot of papers, and I didn't think that much about it. I was looking quickly, but yeah, solutions I saw here, a lot of people got 1/40. So I'm not sure what steps led to 1/40, but I think it might have had to do with having got fractions into your equations, okay? If you got a fraction in your equation, it was unnecessary, you just do this, okay? Makes sense? I'll give you a couple more to work to see if you're getting this. Okay, so we have negative 2x equals negative 7. Now, again, all we've done is to make sure it's really clear. We subtracted 4 from both sides, so that we wouldn't have the 4 there. Then we got an equation, and we subtracted 5x from both sides, so that we wouldn't have a 5x over here. So now we have all our x's here and all our plain numbers over here, and that's a very simple equation to solve. Now we can say, well, negative 2x over negative 2 equals negative 7 over negative 2. But you divide negative 2x by negative 2, it leaves you x. And negative 7 over negative 2, these are both negatives. If we divide two negatives, we get a positive, and it's going to be just plain old 7 halves. Now let's check that and make sure. Okay, so here, let's have that solution now. Check. 3 times 7 halves plus 4 would equal 5 times 7 halves minus 3. Okay, so that's 14 halves plus 4 equals 35 halves minus 3. Now I'm going to do something that's really the easiest thing you can possibly do with an equation. If you have fractions, if you have denominators in an equation, in general, you can multiply by the common denominator. There's only one denominator. Well, you have denominator 2 and implicitly denominator 1 on these two. But if you multiply both sides of this equation by 2, you get this. And let me fix something. 3 times 7 ain't 14, is it? 21. It's not going to work out. It's going to end up with a fraction on one side, no fraction on the other side. So got to check my own check. So that should be 21. Okay. Well, this means we have 2 times this here, 2 times this here by the distributive law. Gotta multiply 2 by this and multiply 2 by this. And similarly, 2 times 35 this is here, and 2 times negative 3 is the same as negative 2 times 3 there. So now we get this, okay? Now, of course, we could write this as 2 over 1 times 21 over 2, 2 divides 2, and so forth. I'm going to go ahead and multiply it out, okay? And when we multiply 2 times 21 halves, we get 42 halves. 2 times 35 halves is 70 halves. 2 times 4 is 8. Negative 2 times 3 is negative 6. So 21 plus 8 should equal 35 minus 6. So the 29 equals 29. And now we're sure we've got it. Notice I've avoided working with fractions every place I can. That's kind of important when you're trying to solve equations in small fractions. All right, I'm gonna move this over here and start working over this side. We have up and down the equation I just solved. Now, the first step here is we're going to multiply 3 by the 2x and by the -1 because of the distributive law. We get, and I'm going to write it out in a lot of detail. 3 times 2x minus 3 times 1. Now, 3 times 2x is 6x, and 3 times 1 is 3. So now we've removed the parentheses using the distributive law again, and now we've got an equation of the same type as the one we just solved. So we're going to do similarly. We add 3 to both sides because we don't want a 3 over here, which gives us 6x equals 2x minus 7. Then we're going to add 7 to both sides. Notice I write down both sides before I add anything to make sure that I'm not missing that step, okay? So I add 7, I add 7. And that's not what I do at all. Because that leaves me no good. Leaves me back to something that looks a lot like this. I'm going to subtract the 2x from both sides. Because of course my goal here is to get rid of the numbers on this side and the x's on this side. So now I'm going to subtract 2x. And 6x minus 2x equals 4x. 2x minus 7 minus 2x. Well, 2x minus 2x is 0. This gives us minus 7. Then we divide both sides by 4. And we get x equals -7/4. I'm not going to take time to run through the check. I've emphasized that enough, but right out then we're going to check. And I can check it kind of in my head. -14/4 minus 1 is -18/4, which gives me -54/4. On that side, we get -14/4 minus 16/4. I'm not sure that's right. So I'm going to check my work. Okay, did I multiply both of these terms by 3? I did. Did that multiplication come out right? I believe it did. This side is still what it was. Oh, you gotta watch me because I do stuff like this. Okay. Yeah, 4 plus 3 is 7, but -4 plus 3 is not -7, is it? KCC, I pretended to make that mistake so I could demonstrate why it's important to check. Actually, I just plain old made that mistake. Okay. So I'm going to change some of these sevens to ones. See. Now I have x equals -1/4. And if I do that, like I get a half minus 1, which is 3/2. And that's plus a half minus 4, which is either my head's wrong or I've got another mistake in here. 3/2, without about it. And that is a half minus 4. I'm sorry, okay. -9/2 there. And over there, it's -3. Maybe I should just stop doing things in my head because that doesn't look right either. So I'm going to do this check. And I'm sorry right over there. No, it still doesn't. Okay. Does anybody see where I messed up my numbers? Take a lesson and write things down carefully. This should be -4 here. This should be -4. Now, if this is -4, this comes out -9/2. And it checks. So watch your clerical errors. I made 2 of them on the same problem. Okay. And I am prone to clerical errors. Okay. At the level of courses I teach, which is like up to multivariable calculus, I very seldom make an error of procedure, but I do make clerical errors. So watch me. And that's why we like to check. And I usually check these things in my head. I checked in my head and I kept getting -9/2 equals -7/2. Because I kept seeing that as a +4, even though it's clearly written as a -4. Okay, so be careful. All right. So again, what we want to see is that after we do the distributive law, we get something that's very much like the first equation. You know, all you got to do is take whatever number you got here and add, subtract it from both sides. And then whatever multiple of x you have here, you subtract that from both sides. And you get something like 4x equals -1. Or where is it? I'm not sure if you can see. Again, by the time we do the distributive law, we get some multiple of x plus a number equals some other multiple of x and a number. Same here. We subtract this number from both sides, subtract this multiple of x from both sides, and we end up with four x equals -1 here. You did this one, we end up with -2x equals -7. In both cases, you're home free when you get that. As long as you don't make the kind of mistakes you just saw me make. Write down the wrong sign, wrong over. Right. Now, I want to look at this last equation, which is x plus 3/5 equals 5/8. Anytime you have denominators in a fraction, find the common denominator, multiplied by both sides. You'll end up with no more fractions. Now, usually you want to use the least common denominator just because it keeps your numbers more manageable. But any common denominator will actually do. Still, try to use the least common denominator. It's less work. Okay, so what we're going to do is we're going to multiply. On both sides by the common denominator. Remember, the equation is x plus 3/5 5/8. So we write it out this way. First, we write x plus 3/5 equals 5/8. And then our common denominator is 40. So if we multiply through this side by 40, we get 40x plus 40 times 3/5 equals 40 times 5 is 200 over 8. Giving us 40x plus I'll write it out, 120 over 5 equals 200 over 8. Now, there's something kind of important to see here, and since I'm multiplying the numerators and doing the division, it kind of obscures that. We'll talk more about that next time. Okay. Now, this is where you got 140. So I'm not sure, thought maybe I was looking at a different equation. So I'm a little clearer on how you got some of the stuff when people got 140. Anyhow, so now we don't have any more denominators. This thing's very easy to solve. And if you don't solve it using the fractions, that's good because it shows that you know the fractions quite well. Okay. Because you change these both to common denominator 40, right? Then you get 24 over 40 and 20 and 25 over 40, yeah. And then you combine the fractions. That works out, but it's actually easier this way. Okay, so 40x plus 24 minus 24 equals 25 minus 24. So it's 140, you check that, okay? Now, the other way, this will often be written out, and I'll show you. And it's getting a little more insight from this. Okay, start here. Actually, I'll just start with this step. You got 40x plus 120 over 5. Plus 40 times 3/5 equals 40 times 5/8. Can you read that? You would do his. Write it out again, so it can be read. Okay, so you got 40. The 40x plus 40 times 3/5 equals 40 times 5/8. 40 can be written as 40 over 1, and you got 3/5. So you got 40 times 3 over 1 times 5, but I'm going to put the 5 here. You got like 5 times 1. We're not going to multiply those out. We're just going to divide the 5 into 40. I'm avoiding cancellation because it confuses people to get it wrong. Okay. So there we have it. Forty over 5 is 8. 3 over 1 is 3. 40 over 8 is 5. 5 over 1 is 5. And we get 40x plus 1 equals 24. Subtract 24 from both sides. 40x equals 1. And there's a step that should be written out here, but I don't have room. But I did go. Actually, kind of there. But there it is. Get the same solution. And what you're really doing is dividing the 5 into the 40. You divide the 8 into this 40. You divide 5 into 40. You get 8. Like here. And that 8 times 3 is 24. If you divide the 8 into 40, you get 5. Okay, that's here. And that's multiplied by 5. 5 times 5 would give you your 25. So make sure you're clear on those steps in whatever way you best understand them. Okay.